For this video, I am going to go through some of the labs for PRG211. Like I mentioned before, I'm not going to go through the actual labs themselves because I don't think that's fair to people who have already done them or haven't watched the video or whatever, figured it out on their own. But what I will do is I'll talk about some of the principles that are covered in some of these labs that I hope will help you when it comes to solving them. So let's start with a problem that's pretty common in there's a lab that you essentially have to calculate what the smallest number is, and there's a lab where you have to calculate what the largest number is. And so I'm gonna let's start by calculating the largest number. I think it's just a little easier to grasp than that. So what we're going to do is we're going to for our requirements. So again, if you haven't watched some of my other videos, I like to do this in 3 steps. The first is define the requirements. What are you trying to do? What is this problem that your program is trying to solve? And I like to just put that as a comment directly in the program. Now, you may find that if you're writing a program, some sophisticated program, you can't write that all in your program, but in this case, we'll do that. The second step for us will be to write down the steps to accomplish this thing in English, or sometimes we might refer to that as pseudocode. And then the third step is to translate that English into the language that you're using. In our case, we're using Coral. So we're going to follow that as we go through some of these. All right. So the requirement for this is to take 3 numbers and determine which is the largest and display the largest. How about like this? The largest number is plus the number. All right. So let's kind of write this out in English. So we know, first of all, that we need to declare 3 number variables. And populate from input. So we'll get them from this input box. If you're like, what the heck does that mean? I'd suggest that you go look at one of our basic programming videos that will talk about that specifically. All right, now we need to determine which is the largest. Notice I spelled this wrong. All right, which is the largest variable number, and then show the all right, so that's not much different from the requirements, but all right. Now, so the first part of this is pretty easy. I'm going to throw one out there for that. And then we're going to go say A equals get next input, B equals. Again, if you're like, what the crap does this mean? Go back and look at one of my basic programming videos, and it will cover this. All right, so this is going to let's just start with something easy. 1, 2, and 3. So if we were to run this program right now, it's just going to setting up these variables, the little mailboxes for these variables, and then it's going to go out and get these 3 numbers and put them in A, B, and C. So that's the easy part, right? And we know somewhere down here we're gonna do something like put the largest number is, gotta spell right. So this will show what we're looking. It's this part right here in the middle that's tricky. In my basic video, I said that programming is hard for 2 reasons: sequencing and logic. And so, we're trying to solve the problem of sequencing by defining the requirements, writing out some pseudocode, and then translating that pseudocode into a program. The logic, on the other hand, is a little trickier. Now, if I have three numbers, 1, 2, and 3, in your head, you just quickly know that 3 is the largest. Well, how do you know it's the largest? And how you didn't necessarily have to go through like these logical steps to decide whether it was the largest or which one's the largest and which one's not. It just kind of comes naturally because over the years, you've done it so many times, you don't really have to think about it. But the computer, we have to tell the computer how to do it. So if you think about it, how on earth do I know which one of these is the largest? So we're going to have to use an if statement. So if I say, okay, this is A, B, and C. If A is bigger than B and A is bigger than C, then I automatically know that A is the largest. Does that make sense? So let me write that out. If A is greater than B and A is greater than C, largest equals A. Okay? And then let's do it again. So if this is true, it does this. Otherwise, it's going to jump down to this next one. Let's do it again. If B is greater than A and B is greater than C, largest equals B. And we'll do the same thing for C. If C is greater than A and C is greater than B, okay, so let's just, hey, that seems pretty easy. Now let's just run it and let's test it. So program runs, gathers the variables, and it decides that the largest number is 3. Oh, that's great. Well, let's see what happens if we change the numbers around like this. Run it again. Okay, well, that even went faster, and it picked out the right number. Okay, well, this works great as long as none of the numbers are equal to each other. So what if we had this? Let's see what happens. Nice, still works. One thing else though, what if it was like this? So the highest number is equal. What? The largest number is 0. There's kind of implicitly in our program here an else that's like this. Right? So what happens in this case is it's not greater than, it's equal to. So it drops down here. These are all false. And it drops down here, and it's essentially giving us largest as 0. So we got to figure out how we go about doing this. And I'll tell you that it's actually just simply adding an equals to each of these. All right, let's try that. Now let's run the thing again. When you're going through your program and you've written it and you think you got it pretty good, so that worked good, right? Try a lot of different scenarios to make sure that it works under all conditions, right? What happens if, for instance, these are all the same? Does it work in that case? Okay, good. So you want to go, use a lot of different conditions. So this is a relatively simple way to calculate, to determine which number of 3 is larger. If you want to now decide how to calculate which one is smaller, the change to this program is very simple. I mean, you probably want to change the name of this variable from largest to smallest. And so these places where you're using largest and you know, your text and stuff like that. But the rest of this is just simply, rather than is a greater than or equal to b, is a less than or equal to b. And if you do that on each of these and change this from a greater than to a less than, it will calculate the smallest. So I hope that helps. Okay, let's see. Let's look at a couple of other ones. So let's see, let me clear this out. Another thing that's pretty common throughout the labs is figuring out whether something is odd or even. And so let's say what we want. We want to take a number and determine if it is odd or even, and print let's say number is, and then odd or even. So display. So if we were to put some pseudocode behind this, we would say declare a number and fill from input. Determine if the number is odd or even. And I'm going to say show results. Okay. Now, if we come down here, we could say number. Gotta spell it right. What is, and then I'm actually going to, rather than we can't have a variable in Coral that's odd or even because it only has numbers. So here is where we'll make our actual determination. Okay, because we're going to display this every time, and the thing that we'll display that's different is deciding whether they're odd or even. If that makes sense. So let's start with a number like 1. Just like when we were talking about what's the largest of 3 numbers, how do you know that 1 is an odd number or an even number? I mean, we know it's an odd number, right? But how did your brain calculate that? You know, what if it's a bigger number? How do you know that that is an even number in this case? Well, I don't know. In this case, like if you have a big number, I look at the last number here, and then, I know that a 1 is odd, a 2 is even, a 3 is odd, a 4 is even, a 5 is odd, a 6 is even, and so forth. And so I just know it without really thinking much about it. The rest of the number doesn't really matter. It just matters what the last digit is, right? But ultimately, the way that we calculate whether something is even or not is we take the number and we divide it by 2, and then if remainder is 0, it is even. Otherwise, it is odd. So this is the calculation for whether something is odd or even. We divide it by 2. If it's divisible by 2 without any remainder, then it's an even number. So 592, if we were to divide it by 2, it would be whatever, but it would have no remainder. Okay? So in most programming languages, there's a thing that we call a modulo, or sometimes it's called a modulus. But basically what it does is it divides 2 numbers, and it doesn't return the result of the division. It returns the remainder. So we can take advantage of this, and the syntax would be, let's say, number 1, and then we use the % and number 2. So it's going to take this number and divide it by this number, and it's going to return the remainder of these. So all we really care about is whether it's whether it's odd or even, or we only care about the remainder. All right. So at one point, I don't know, did I do this already? Let's start onto this. I'm going to have an integer called number. We're going to have number equals get next input, and then now we're going to use an if statement. So we could do it this way. I like sometimes to use a kind of an intermediary number, remainder. So what if we did this and we said remainder equals the number, and remember this by 2, because we said that we need to take a number and divide it by 2, and this will return the remainder. Now, if we simply have an if statement that says if remainder equals 0, so we got to use the double equals here because we're not assigning a value. We're just going with the we want a logical expression, or we want to evaluate it whether it's true or false. Then we could say put even. Now there's a space already right here, so I'm just going to leave this without a space. And hey, let's just put a period on it so we got the whole sentence going here. And then I'm going to say else all right, so let's see how this works for us. So going through it, we've got our number that we're pulling from input. We've got another one that's going to store the remainder. We're displaying the first part of our output here, and then we're calculating the remainder. We're using it in an if statement. If it equals 0, then we know it's even. Otherwise, we know it's odd. So let's see what happens when we run this. Okay. All right, let's try it again. How about a number like 111? What's that? Okay, 11 is odd. Very good. So now one more I want to throw at your way. If I was to use, let's say 0 here. Okay, so it says that it's even because, if you were to when you're calculating this, 0 divided by 2 is actually 0, remainder 0. So the remainder is 0, and that's why it's showing as an even. Now, I don't know if technically 0 is actually even. It's not really even or odd, but for the purposes of this, we're going to call it even, right? All right, I want to show you one more to kind of wrap it up here. So one of the things, so there's a lab, and you know what it is, that where you have to decide based on the number of a highway, whether it's an interstate highway or an auxiliary highway, whether if it's an even number, then it goes east to west, it goes east to west or west to east. If it's an odd number, it goes north to south. So you have to determine that. But the hard part is, and this is where I'm going to focus, the hard part is if it's an auxiliary number, like let's say the number is 405, what you have to do is you have to tell me what the primary interstate highway is as well. So the way that the auxiliary systems work, the second 2 digits, so if it's a 3-digit number, then we know that it's an auxiliary highway. And then we pull the last 2 digits, and these 2 digits tell us what the primary highway is. So 405, it's in California. It is, the primary is I-5. And so then you can, print out the rest of the blah, blah, blah about it being, it's an auxiliary, but the primary is 5, and it heads north to south because or north and south because it's an odd number. So what we want to really do here for this is take an auxiliary highway and extract the primary highway from it and display. All right. So we know we need to declare highway variable. I'm going to put on here too highway and primary. And load highway from input. And then determine what the primary variable is, highway is. Show primary highway. All right. Okay, so let's start this out. Integer highway, integer primary, highway. Okay, we got all that figured out. Now, down here at the bottom, we're going to put primary to output. We got to calculate primary here. So this is a little tricky. Again, just like all of these, you know, our brain just immediately figures this out by just slicing off the bottom two. And in some programming languages, we could do that because they may have a function that will slice off pieces. But in our case, with Coral, we can't do that. So we've got to figure out a mathematical way to extract 05 from 405. So let's think a little bit about this. If I was to get 405, to get 5 out of 405, if I took 405 and I subtracted 400, then I would get 5, right? But I also want it to be able to work with any other 3-digit number, right? So instead, what if I could take 405, divide it by 100. If I took 405 and I divided it by 100, then it would be 4.05, right? In most languages, when I can do that, this is great. I can do mathematics like this, but 4.05 isn't an integer. It's a floating point type variable. So I can do something that's called integer division. And all that means is that when I divide 405 by 100, the result of that is 4, because it doesn't have any place to put the decimals in an integer. So it just wipes them out. So with that in mind, if I could do this, 4 divided by 5, this results in 4. And then I could take that number and I could times it by 100. Then the result of this would be 400. And then, of course, if I could take that 400, I could do this and I could get 05. Now, that's a long way of getting to ultimately what I want to do here, which is this. Primary equals highway, that's like 405 here, minus, and then I'm going to put this in parentheses. In parentheses here, highway divided by 100. Again, it will do integer division because this is an integer and this is an integer. And then it will times that by 100. And if you, going back to the order of operations, you probably learned in math class sometime, this is going to do this calculation in the parentheses first. It'll do the innermost parentheses first. Then it will do the next innermost, which would be, so it's going to make this calculation. In this case, it would be 4. And then it'll do this calculation with 4 in there, so it'll be 400. Then it will do the subtraction here. So if this works out right, the result is 5. Now it didn't give us 05, and that's okay because it's a number. It's not going to give us it's not going to show the leading 0. But this allows us to peel off the O5 as the primary. And then, of course, you can go through the rest of the stuff that you need to do for that lab in order to show that. So I haven't gone through every single thing, and I've only gone through the first 2 weeks of labs here and just covered what is really in the first 2 weeks. But I hope that this helps you to be able to understand the principles associated with these labs. Thanks.